This is the worksheet from in class on Tuesday, February 5th. This is kind of like a good review for the first half of the similarity section of Unit 5. So it covers all the way up until what we don't cover in here is the word problems and applications. We don't cover the angle similarity, side similarity, side angle side similarity, and we don't cover the proofs. But it covers everything else before that. So it's a good part 1 review. Okay, first question here: if polygons are similar, then what do you know about the corresponding sides and the corresponding angles? We know if we have similar polygons, the sides are going to be proportional. Right? The ratios between each set of corresponding sides is going to be equal, and since those ratios are equal, the sides are proportional. And the angles are congruent. So since the angles are congruent, it tells us our similar polygons are going to be the same shape. Since the sides are proportional, they're not necessarily going to be the same size. They can be larger or smaller at a proportional rate. All the sides of that polygon will be larger or smaller at the same rate. They're proportional. Okay. Number 2, given the similar figures, name all pairs of corresponding sides and angles. Look at the similarity statement to help. So number 2, we have QP. So what's going to correspond with QP? It's going to be ED. Okay, we can get that from the diagram. We can also get that from up here. So QP and ED. PR corresponds with DF. We can get it from the diagram. We can also get it up here. PR corresponds with DF. Okay, then RQ is going to correspond with FE. Okay. RQ and FE. Angle Q and angle E are congruent. They're corresponding. They became same corresponding location. So Q and E, P and D, and then R and angle F. Okay. So they then, on the part below, want us to use this information to write a statement of proportionality for each. So we know QP is to ED as PR is to DF as RQ is to FE. LM. So this one's harder to see because it's rotated. It's not as straightforward as this one. So 2 ways we can do it. We can either look at the numbers, look for the 2 smallest sides. So LM is the smallest side of this triangle, so it's going to match up with RS because it's the smallest side of the other triangle. But let's look at the similarity statement where we can see LM is the first 2. So RS is going to be the corresponding side because that's the first 2 of the second, written in the second triangle. So RS. L corresponds to R and M corresponds to S. MN is the last 2. So it's going to be ST. MN and ST. And then we have NL and TR. NL and TR. Those are the 2 longest sides. Angle L corresponds with angle R. L and R. Between the long and the small, between the long and the longest and the shortest, longest, shortest, L and R. Or we can get it from the diagram. Angle M is congruent to angle S, and angle N is congruent to angle T. Our statement of proportionality, so LM is to RS, as MN is to ST, and NL is to TR. So these are the ratios for each pair of corresponding sides. That's our proportion. AB corresponds with HG. AB and HG. So it's rotated around 180 degrees. BC is going to correspond with GF, so the 2 in the middle. CD is the last 2. It's going to correspond with FE. CD and FE. And the last one, DA, is going to correspond with EH. Okay, A and angle H, angle B and angle G, angle C and angle F, and angle D and angle E. And then our statement of proportionality, we're just simply making ratios out of our 4 pairs of corresponding sides. And a proportion is where we have our ratios equaling each other. So AB over HG, BC over GF, CD over FE, and DA over EH. So it's 2, 3, and 4. And again, we can always flip these if we wanted to, but you have to make sure all the, right, if we made this HG over AB, then this one would have to be GF over BC, FE over CD, and EH over DA. We'd have to flip all of them. Right? You can't have one from the numerator from the first polygon and one in the numerator from the second polygon. It has to be, for all the numerators have to come from this one, and all the denominators from this one, or vice versa. All the numerators would have to come from here, or all the denominators from here. Okay. So that's 2, 3, and 4. 5. So they want complete the similarity statement for the similar figures and then find the scale factor. So we want to write a similarity statement and then find the scale factor, also known as the similarity ratio. It's going to tell us how much bigger one triangle is from the other, or one polygon is from the other. So let's start with the first one. L is between the small side and the medium side. So that's going to line up perfectly with R. K is between the shortest side and the longest side. So that's going to line up perfectly with Q. And then M is between the longest side and the middle side. It's going to line perfectly with S. Scale factor. It doesn't matter which corresponding pair we pick. We want to find the ratio between a set of corresponding sides. Okay, so let's just do LK and RQ. Okay, which is going to give us 9 over 6, which is going to give us 3 halves. So our scale factor is 3 halves. Okay, we could have also done 6 over 4, which reduces to 3 halves. We could have also done 12 over 8, which reduces to 3 halves. Okay, we could have also flipped it, done 6 over 9 and got 2/3, 4 over 6 and got 2/3, 8 over 12 and got 2/3. So this triangle, first triangle, is 3 halves times bigger than the smaller triangle. It's 1.3 halves is equal to 1.5. So this is 1.5 times bigger than this triangle. This triangle is 2/3 the size of this one. So if we take our ratio, 6 times 1.5 is 9. 8 times 1.5 is 12. 4 times 1.5 is 6. And if you flip it, instead of 3 halves, we would have 2/3. 6 times 2/3 is 4. 12 times 2/3 is 8. 9 times 2/3 is 6. 2/3 of 9 is 6, and so on. Okay. Number 6. So CBAD is going to line up with YXWZ. Okay, scale factor, let's just do the first one, CB over YX, which is 6 over 8, which we reduce to 3/4. Okay, that's our scale factor. This triangle is 3/4 the size of this one, or 0.75 times the size of this one. Right, 8 times 3/4 is 6. 4 times 3/4 is 3. 8 times 3/4 is 6, and 4 times 3/4 is 3. Okay, we could have flipped them. 6 times 4/3 is 8. 3 times 4/3 is 4. 6 times 4/3 is 8, and 3 times 4/3 is 4. Okay. This triangle, or this polygon, this quadrilateral is 4/3 times as big as this one. This one is 3/4 the size of this one. All angles are congruent. Same shape, different sizes. R, S, P, Q. So N, J, F, G. We can do RS over NJ, which is 6 over 15, which reduces to 2 over 5. Right. Divide the numerator and denominator by 3 each. We get 2/5. We could also have done 4 divided by 10, which would have given us 2/5. We could have done 10 divided by 4, which would have given us 5/2, or we could have done 15 over 6, which also would have given us 5/2. So this one is 5/2 times as big as this one. All the sides are. And the sides of the first one are 2/5 the size of the large one. So 15 times 2/5 is 6. 10 times 2/5 is 4. Okay, number 8. What lines up with H? That's got the 3 arcs, so it's going to be E. Lines up with J, has 2 arcs, so it's going to be F. Okay, lines up with G, is 1 arc, so it's going to be D. Okay, EFD. Let's take HJ, corresponds with EF. HJ corresponds with EF. So that's 24 over 18, which if we divide the numerator and denominator by 6, we're going to get 4/3. Could have also done 20 divided by 15 is 4/3. 12 divided by 9 is 4/3. Okay, we could have also gotten 3/4. So this triangle is 3/4 the size of this one. This one is 4/3 times larger than that one. 9 times 4/3, 12. 15 times 4/3, 20. 18 times 4/3 is 24. And again, vice versa. 24 times 3/4, 18. 20 times 3/4, 15. 12 times 3/4, 9. N, PM corresponds with N is J. P is going to be K. Then we go to M, which is going to be L. Okay, let's just do NP over JK. So that's 6 over 12, which is 1/2. Okay, so this triangle is twice as large as this one. This one is 1/2 the size of that one. Right. 12 times 1/2, 6. 20 times 1/2, 10. 16 times 1/2, 8. 8 times 2 is 16. 6 times 2 is 12. 10 times 2 is 20. Last one, KJML. So KJML, FEHG. So ML here over HG is going to give us 4 over 5. Okay, 4/5 or 4/5. Okay, we could also do 5 over 4. So this ends up being a square because all the sides are going to be the same and angles are all 90 degrees. So we're going to get 4/5 times 5 is 4. 4/5 times 5 is 4. Or again, we could do the inverse, 5 over 4. 4 times 5 over 4 is 5. 4 times 5 over 4 is 5. What did I say? 5? Yeah. 5 times 5 over 4 is 5. Next page. Right, the two polygons are similar. Write a proportion and solve for x. So since they're similar, we know the sides are proportional. So we can write a proportion using the information they're giving us about the sides. So number 11 here, we know that 5 is going to correspond with x, 2 is going to correspond with 1, and 4 is going to correspond with 2. Okay, so here's our whole proportion for the whole thing. We don't need all that information. We can just focus on certain parts of it. So 5 over x, right? That's going to be enough to solve for x. Okay, cross multiply. So 2x is going to equal 5 times 1. 5 times 1 is 5. We divide both sides by 2. X is 5 halves. That makes sense because our ratio would be 4 over 2. It'd be 2. Right? This triangle is twice as large as this one. This one's half the size of that one. So 4 times 1/2 is 2. 2 times 1/2 is 1. 5 times 1/2 is going to be 5 over 2, which is what we got for x. Okay, next one, 28 is going to correspond with x. 24 is going to correspond with 6. And 20 is going to correspond with 5. Okay, again, they're giving us extra information. We can just use this right here. So 28 times 6 is going to equal 24 times x. That was 168. Divide by 24. X equals 7. 168 divided by 24 is 7. And the last one we have 3 corresponds with x, and 4 corresponds with 6. Cross multiply. 18 equals 4x divided by 4. 4.5 equals x. 4.5 or 9 halves. 14, 15. Okay, they want to complete the similarity statement for the similar figures and then find the scale factor. Next, write the proportions and solve for the missing lengths. So there's 3 steps for each one. First one, we want to write a similarity statement. So let's we can name this in 6 different ways. Let's just name it a LKJ, triangle LKJ. That's going to be similar to, right? So our similarity sign. What lines up with L is Q, R, P. Second, we want a scale factor. So we can pick any pair of corresponding sides. I'm just going to pick the first two, LK and QR. We want to find out what the ratio is between them. So LK over QR is going to be 18 over 12, which reduces to 3 halves. 18 divided by 6 and 12 divided by 6. All right, which is about 1. It is exactly 1.5. Okay. Third thing we need to do is solve for the missing lengths. So we know 21 corresponds with y, x corresponds with 20, and 18 corresponds with 12. 21 over y is going to equal 18 over 12. We also know x over 20 is going to equal 18 over 12. To solve these two equations now, we cross multiply, so that's going to give us 18y equals 21 times 12. So 18y is going to equal, I forget what that was, 21, 12. $252 divided by 18, and y was equal to 14. Solve the other one. We're going to get 12x when we cross multiply at 18 and 20. So 12x is going to equal 360 divided by 12. X is going to equal 30. The other way we could have done it is we know the scale factor is 1.5 or 3 halves. So we could have put here, instead of 18 over 12, we could have put 3 halves. 21 over y equals 3 halves. 21 over x over 20 equals 3 halves. We could have also known that this triangle was 3 halves as large as this one. So we could have done 20 times 3 halves. 20 times 3 halves is 30. Okay. Or we could have done, and then to find y, we know if we flip it from 3 over 2 to 2/3, 21 times 2/3 is 14. Okay. 21 times 2/3 is 14. 18 times 2/3 is 12. 30 times 2/3 is 20, and then again vice versa. 14 times 3 halves is 21. 20 times 3 halves is 30. 12 times 3 halves is 18. Number 15 here, so we want to write a triangle similarity statement. So let's just start here. PLMN is similar to triangle KGHJ. Those triangles are similar. Okay. Scaling factor. So MN over HJ, those are corresponding sides. That's going to give us 9 over 6, which is going to give us 3 halves. So our scaling factor is again 3 halves. And from there, we want to solve for x and y. So here x corresponds with 8. And then 6 corresponds, we can pick 15 over 15 over y, well, 9 over 6 or 6 over 4. So we have x over 8. We want to set that equal to one of the other ratios. So we can make it 9 over 6 or 6 over 4. 9 over 6. Okay, cross multiply, 6x equals 72. Divide by 6, x equals 12. Okay. To find y, same thing. So 15 lines up with y. And we have to set that equal to one of the other ratios. So let's make it 9 over 6. Okay, 9y is going to equal 90. Divide by 9, y equals 9. So you don't need all 4 ratios written all the way out. You can just pick 2 of them to set up a proportion to solve for x or y. 16. Same thing. So we want to write a similarity statement first, and find the scaling factor or similarity ratio, and solve for x and y. Those weren't triangles. I don't know why I wrote those as triangles, but they weren't triangles. Okay. So here we have similarity statements. So quadrilateral, I don't know, KLMJ. KLMJ is similar to quadrilateral, corresponds with K is P. So PQRN. Scaling factor, so we just got to pick one that's going to work. So how about KL over PQ? That's going to be 11 over 22, which is 1/2. Okay, 6 over 12 is 1/2. Let's find our ratios now. So let's solve for x. So x over 16 is going to then equal 11 over 22. Or we could have put 6 over 12, or we could have put 1/2, because we know that all these are 1/2. 11 divided by 22 is 1/2. 6 divided by 12 is 1/2. Cross multiply. 22x is 16 times 11. 176 divided by 22. X is So 22, 88, 8. 8 sounds right. Yep, 8. Okay. So for y, so what corresponds to y? It's going to be 10, so 10 over y. And we can make it again 11 over 22. So 11y equals 220. Divide by 11, y equals 20. Okay. Next one is flipped around a little bit. So we have triangle DEF. Right, that's going to be similar to triangle JHG. Okay, D corresponds with J based on the arcs, right? D has 2 arcs, J has 2 arcs, so D corresponds with J. E has 3 arcs, so E corresponds with H, and then F corresponds with G. In our ratio, okay, we know FE and GH. That's 20 over 15, which is 4/3. And we could have also got 3/4. So that's our scaling factor. Okay, third, we have to solve. X corresponds with 18. 20 corresponds with 15. Okay. 18 times 20 is 360. That's going to equal 15x. Divide by 15. You get 24 equals x. Here then, 16 and y are going to correspond. Again, 20 and 18 correspond. Cross multiply, we get 20y equals 16 times 18. 16 times 18 is 188. That's not right. Is it? Whoa, no. 16 over y. This is what you guys are doing in class. I'm sorry. I fully apologize. 20 over 15. Okay. 16 is to y as 20 is to 15. 20y, so 16 times 15, which is 30 times 8, which is 60 times 4, which is 120 times 2, which is 240. And so 16 times 15, 20y is 240. Divide 20, y equals 12. So that's most of the stuff you need to know. I think if you know everything on there, you should be at least able to get a 60% on the test, similarities test. The other stuff we need to add to it are application problems, some more complicated ratios, the angle, side, angle, side, stuff that we've already done, and then proofs, which we will do later this week.